Hello, everyone. Okay, let's start this talk with a little confession. So, I don't think I like drawing sketches. Like, and the reason is like when I draw sketches, like people laugh, and also like in the first place, why do even people give me the paintbrush, even though it is digital? Like, people need to start having trust issues. So I was like, I'm a software engineer and I like coding. So like, why not build a tool which will help me code more and draw less? So today we'll talk about the motivation behind this tool. So I've given a little spoiler anyways, and also the approach on how you can build this tool for your organization. And then we will actually build this tool, do a little walkthrough, and why this tool will be actually beneficial to you. And in the end of this talk, we'll take some questions. So about us, I am Yash Saboo. I'm a software engineer at Bloomberg in the New York office, and I've been at Bloomberg for more than 2 years. And before that, I was in academia studying computer science.
Yeah, so my name is Kang Bay. So I'm in the same team as Josh, and I've been with Bloomberg for a little bit over a year. But before that, I worked in IBM Quantum as a backend software engineer for about 2 years. And prior to that, I was studying computer science at a university.
All right. So what was the motivation behind this tool? So let's say your business is growing at light speed, all right, which it was for us last year. So our team multiplied. Like we genuinely had more than 30 plus engineers in a 60 engineer team. So let's say now that your team is multiplying, your team is growing. So of course, you want to give those new engineers a great onboarding experience. So of course, you want to start mentoring people. And when that happens, something which we found while I was actually mentoring is that there were a few gaps. And when I say gaps, it was like honestly everything, everywhere, all at once. And what I mean by that is just like we had the information, but the wisdom that we were actually imparting, they were just not equal. And what I mean by that is we had all these documentation, we had all these diagrams, but there were just like multiple sources. So for instance, somebody would just like to document in GitHub wiki pages, or somebody would like to document in GitHub, like just in a different software tool. And on top of that, there's multiple styles of sketching. So for that, what I mean by that is somebody likes to like be very detailed. Somebody would like to be just like very, I don't know, concise. And on top of that, it also matters who your audience is. You won't be drawing the same diagram for the system architect and also, let's say, an upper management, because the upper management does not want to see, hey, how your services are interacting with each other. All they want to know is how is client interacting with your services. And also, there was no single point of access. We just had everything everywhere, as I said. So, what is the problem? When it comes to documentation, we like a monolithic architecture over a distributed one. And what that means is, let's say you add a service today, and automatically you have to change your documentation or your diagrams in multiple places. And also, it is very easily like your documentation can get out of date. So how to solve this? In your tool, which that can solve, what is the requirement? So first is it should be single source of truth. It should automatically generate and refresh as soon as your system architecture changes. Then you want to make it an immersive experience. What that means is, like right now, all the diagrams is just a PNG image. Like, why is that? Like, we are hiring user experience engineers just responsible for the sake of making the user experience better. So why can't our architecture diagrams be just better? Why can't they be dynamic in nature? And also, why not let diagrams speak at mind? Like, why does it have to be just like the component name and like, okay, how does it invoke or whatever? Why can't it also store like, hey, what is the GitHub link? Is there a tutorial, like a video tutorial for that particular component? Can it not show all those metadata in it? So we built a tool around it, and Kangman is going to talk about the approach behind it.
Thanks, Josh. So yeah, before we dive into the actual implementation of the solution, let's briefly go over what an architecture diagram really means. So architecture diagram is pretty much a network of components and services, and just pretty much mapping out how each components and databases or whatnot interacts with one another. So, who does relationships the best? The human beings, right? So using this approach, we could definitely graph the product ownership for all of the components as well as the components to components relationships. So yeah, let's use graph databases and Python to solve this problem. So prior to going into it, I'll briefly go over GraphDB. So graph database pretty much stores data into a node and relation form. And so nodes could represent the components that you're trying to represent. And the relation is pretty much the component to component relationship on how it interacts with one another. So if you look on the bottom right, there's the graph of Dork, Yash, and myself. Just intuitively looking at this graph, you're able to infer that like we are all coworkers, and Yash and I both report to Dork, and pretty much maps how we work with one another. So for our implementation, we use Neo4j specifically because it has great Python support. But pretty much you could use any graph database out there to emulate what we did today. So yeah, so let's get a little bit into the code. So this is just an example of how you would add a node. So Neo4j uses a query language called cipher query language as opposed to structured query language that a relational database would use. And if you look at this snippet right here, it's using a create keyword to create a node, and you're defining the type and the name of the node. But pretty much you could add any attribute you might find useful into this node without having to predefine a schema for it. And after that, you return the node that you just created, and you could pretty much use this result to as an object to refer to it later on. So now we created a node. Now let's create a relationship. So we're using the match keyword to grab the two nodes that we're going to create a relation for, and we're using the where clause to identify which node you're interested in. Then you're pretty much using the create keyword again between the node that you're interested in, A and B here, and you're pretty much defining the relation that you want and what kind of information you want that relation to store. And you could define the direction of the graph using this dash sign or the greater or less than sign to represent the direction, or it could be unidirectional. So yeah, now that we went over GraphDB, we know that instead of static diagrams, which is just a PNG image, just like what Yash said, it could represent data. It could represent more data, and you're able to kind of get an intuitive idea of what each component does without having to look at the diagram, then look somewhere else for the documentation itself. So yeah, this is a sneak peek of Neo4j right out of the box, and for the demoing purposes, we just use the right out of the box browser, and it's pretty much lightweight, so that's pretty much why we used it. But you could also hook it up to a different React.js framework, and Sigma.js and Cytoscape is just a few of the many, but there are definitely way more support out there. So yeah, let's build our tool together. So to build our tool, we're gonna first spot the information that we want to store. Then we're going to scrape the data that we just identified. We're going to merge all of the data that we scraped into a single point of truth. Then we're going to load all of that data into a graph database, and we'll graph it. And lastly, you're going to continuously just repeat the steps 1 through 4, adding more information, identifying more information to make a diagram more informative for the users so that they could get a holistic picture of what their product actually does. So yeah, let's build our tool together. So let's start with GitHub that we all use. So as you can see here, all of this data could be scraped, but in this example, we'll just scrape this readme.md, and we could store the entire contents of this readme file as one of the attributes for the node itself, so that when you hover over it, you could get an idea of what that node does. So this is the graphical representation of what we just scraped. And as you can see on the right, here's the description that we just uploaded into the GraphDB. And like I've mentioned before, you don't need to define a schema prior to uploading data for you to be able to store data. So you could pretty much set up any kind of parser using regular expressions or something to kind of scrape out the data that you might find is more useful in the GitHub repo. Then you could store it into the graph database. So we're using the GitHub 3 API to scrape more components other than the interactive. And we're pretty much scraping all of the other services that interactive is interacting with. But yeah, we don't have any relations between those components, so we don't really have a view of how those components are related to one another. Whether they're upstream or downstream, you don't really know. So we decided to use distributed trace to figure out the component-to-component relationship. And as you can see, so the distributed trace, you're able to highlight what service is calling what service and pretty much identify the downstream, as you can see here. So front end is calling the customer and MySQL. So using this, you could identify the relationship and you could add relationship into your graph. Also, another thing you could do is scrape the requirements.txt file. And using this, you could pretty much add versioning to kind of set a fixed version of all of the libraries your service is using. And this could be useful when you're debugging versioning conflicts and whatnot. And also, lastly, you could pretty much store the relations with other databases or other services as a JSON file like we have here. We're just calling it interactive JSON, but you could pretty much store this relationship. Then you could scrape this file later, then load it to a database. So yeah, now we have the graph and the relationship. As you can see, all of the components are connected. You're able to identify which services are downstream, which services are upstream by looking at the direction of the relationship. But we don't really know who owns what component. So if something goes wrong in one of the services, you don't know who to reach. So we're going to scrape the people data from GitHub as well. So if you go to the contributors, this data you could also scrape using GitHub 3 API. And now we have this org chart that, this is more refined than what you could probably scrape in the the contributor. But if your organization has chain of command mapping as an API, then you could pretty much leverage that as well. So we have all of the data that we just scraped. So on the left, you have the product ownership, the contributors. Then you have all of the attributes that we scraped in the beginning. Then we have the relations of how those components react with one another. Then we also have the team information that we just scraped from GitHub as well. So yeah, Yash is gonna go into what we're gonna do with all that data.
All right, so he walked us through all the I would say the basic example, the GitHub, the organization. Of course, your organization itself can have much more data that you can add to the system architecture. So this is very extensible, and you can add more data to it. But let's say whatever we have scraped till now, so you can already see that how they are related to each other, who is responsible, and Now, the beauty of this is you can create different query and create different views. So let's see three examples. So first example is, let's say you have this right now. This is just for one tool. Also remember, like for an organization like ours, like we have like almost 8,000 engineers. We have, I don't know, like I don't know, more than thousands of repository. Now imagine an architecture diagram just filled with those components and those structure. Now let's say in that you want to figure out, I just want a view of services. So you can write a very simple query saying that, hey, just give me the service since you've already added that metadata. And you can do this in Python also. And you can create different screens just for those queries specifically. Now, second is, this is one of my favorite. It's like, hey, you wanna, this usually comes up, it's that sometimes some service is just running on your machine and you're not able to figure out, hey, is that being actually used or not? So you can figure out all the deprecated service using this. So since you've put all the distributed trace information, how they are being invoked, when was it last accessed, and those kind of information, you can figure out, hey, are there any services which have not been, let's say, used since 5th May? And then it's either that service is running and nobody is using it, so it's either a newer service or it should be just like looked up and like just deprecate. The third is, and we use it actually pretty often, is like if you want to figure out how in cross department, what are the downstream. So sometimes, so let's say in this case, you want to figure out all the downstream or the databases which a certain service is impacting. And what happens usually is, let's say just JSON load, right? That is owned by your team. And dtrace service is completely owned by a different department and you do not have direct access to it. But still you want to know, let's say if your JSON load service, that just goes down, like what all databases are you impacting? So you can just write a very simple query and try to figure out, you can map the relation. Like, hey, what are all those? So if you just map it out, you'll see that, hey, you're impacting the Splunk database and you're also impacting the via Kafka topic, via interactive, and then you're impacting the Neo4j database. So this helps quite a lot because specifically in our example, what happens is that we have like an SLA of like in 1 hour you have to fix some client issue. And then we are working cross department trying to figure out, hey, what is the impact, what is the level of severity and those kind of things. Now, there are 50 people on the same call trying to figure out that. If like we use the service and we can actually do that impact analysis pretty quickly. So why this tool will actually help you out? So first is zoom in and zoom out. So using this, everything will be in one place, right? Now you can create different views for the same system based on who the stakeholder is. And it, of course, becomes one shop, document shop, static versus dynamic. So now this one is, you can actually play around with this UI. Like there are really great, even React.js, even Node, like Neo4j. Like you can actually interact, you can like just focus on one node, you can focus on the nodes that you are interested in, and also add automation to it. So like now the idea is that this tool will automatically scrape. Like we've been put in a cron job that runs every day and tries to figure out, hey, what are the new services? Has the team changed? Or any other distributed trace that happens every day. And it enhances the user experience because now those diagrams are not just static. And also the power of merge and multiplicity. So this is very important as if you have a huge team, like this enhances your collaboration. What that means is that you're isolating the responsibility as long as the component that you own, you are maintaining the document, you're maintaining that interactive.json file properly, you are done. This tool will manage, merge all those interactive.json into one, all the other data into one, and keep your architecture diagram and documentation in one place and update it. And also, this is specifically great for huge organizations like ours, where you have like different managers, different departments, and you want to figure out, hey, what is the actual impact across different, I would say, teams. So we are ready to take questions if you have any, but I just also want to mention, like, if you don't want to hook it up to a React.js and you just want to use a lightweight like Neo4j UI directly, so this is how it happens. Like, if you want to see, you can just click on this, and if you let's say you double click, you figure out, hey, what is this particular Kafka topic being invoked by? And then if you wanna get another view, hey, okay, who owns Interactive? So you can again click on, okay, this is being owned by like both of us. So let's say both, like right now, both of us are right now in Lithuania. We are not on call. So like, whom should we reach out to? So let's see which part of team we are in, and then you can figure out, oh, okay, maybe Dwat, like their manager is available. So this is like helpful in debugging tool. It is trying to, it will help you figuring out the entire system architecture diagram automatically. Any questions?